Hey guys, this is CHEMPLIFIED and today we will talk about Lewis octet rule, also known as Lewis dot structure. We will talk about Lewis dot structures and how they are formed. So for that, there are a few rules. So let's take a look at those rules. First of all, what is it about which Lewis dot structure talks about? Lewis dot structure talks about the structure of the molecule, as the first statement suggests, structure of molecules on the basis of valence electrons, of different atoms present in one molecule. Right? What is the meaning of octet rule? Octet rule simply means 8 electron in valence shell. Octet rule simply means total number of electrons are 8 in the valence shell of a given atom in the molecule. Now there is one exception. There is only one exception. What is it? It is that octet rule for central atom. Remember that. Octet rule for central atom can be neglected for some molecules. For example, I can take SF6. In this particular case, the central atom have more than 8 electrons. Now, since Lewis was constructing the structures, he himself find out that there are a few exceptions about his rule. And if he break the rule for central atom, then he can make structures more easily. So this is the only exception that you should remember. Octet rule for central atom can be neglected for some molecules, only for the central atom, right? Now we will talk about the rules. Now there are points or rules that you should remember before making Lewis structure. Rules for selecting the central atom. The first rule that you should know is how to select central atom. For that you should know about a few things. First thing, hydrogen and fluorine can never be central atom. Remember this, hydrogen and fluorine can never be central atom. Carbon, silicon, phosphorus, nitrogen, oxygen, sulfur, chlorine can be central atom. Now what is it that decides which one is central atom and which one is not? For that you can take general things like least electronegative atom. If there are, let us consider water. Now there are 3 atoms, 2 hydrogen and 1 oxygen. Least electronegative. Now oxygen is really electronegative, but look at the second one, largest size. Oxygen is larger than hydrogen. Or highest atomic number. Oxygen have atomic number higher than hydrogen. Or least in number. Oxygen is 1 and there are 2 hydrogen. Which is lower in number? Oxygen. So out of 5 conditions, 4 conditions are in favor of oxygen. So the central atom in this case will be oxygen, and we all know the structure of water molecule is like this. So thus oxygen is central atom, right? So this was the first rule which tells us about the central atom, how to select the central atom. This video can be a bit longer, so please be patient. The second rule, octet of corner atoms must be complete. For hydrogen, doublet must be complete. We will talk about hydrogen in a bit, but remember the statement octet. Octet means 8 electron for corner atoms must be complete. What is the meaning of corner atoms? For example, CH4. There are 4 hydrogens. Now these 4 hydrogens are the corner atoms. So octet for corner atoms must be complete. Means the corner atoms should have 8 electrons. But in our case, hydrogen is there and it is already written for hydrogen, doublet must be there. What is the meaning of doublet? For hydrogen, 2 electrons should be there in the outermost shell, because hydrogen can have only 2 electrons. So for hydrogen, doublet must be complete. So in this particular case, every hydrogen atom has 2 electrons in the outer shell, which are shared. By sharing of electron, it is completing its doublet, right? Now the third one, let me erase the example. Third one is really important. Third one talks about the central atom tries to remain in maximum covalency. What is the meaning of covalency? In simple terms, you can say that covalency means the maximum number of bonds that central atom can make. I repeat, covalency simply means the maximum number of bonds that central atom can make, or the maximum number of electrons that the central atom can share for bond formation. Remember these two statements. There are a few general examples about which I will talk. First one is oxygen. What is the maximum covalency of oxygen? The maximum covalency of oxygen is 2. That is, oxygen can make 2 bonds, and we all know about it. Now, what is the maximum covalency of sulfur? The maximum covalency of sulfur is 6. Now comes an interesting case. Nitrogen is pentavalent. That means nitrogen have 5 electrons in the outermost shell, and it can share 5 electrons. But the covalency for nitrogen is 4. The number of bonds that nitrogen make is 4. Why? Because in case of nitrogen, first thing is there is no d orbital present in nitrogen, right? Secondly, nitrogen forms NH4 plus. But in this case, 4 bonds are formed and one hydrogen is taking 2 electrons from nitrogen directly by coordinate bond. That is, nitrogen is donating its lone pair to single hydrogen atom. Always remember, nitrogen can never have a pentavalent covalency. That's it. Now what about phosphorus? Phosphorus has a covalency of 5. Carbon has 4. And we all know that carbon show the covalency 4. What is the covalency of chlorine? What is the covalency of chlorine? Generally, you see that chlorine is making single bond. But in reality, chlorine can have a covalency 7. I repeat, chlorine can have a covalency 7. Why? Because of the presence of empty d orbital. Empty d orbital. Because of the presence of empty d orbital, chlorine can make 7 bonds. So covalency is 7. Right? Maximum covalency, I repeat, according to the need. Right? So these are the second and third rule. Now let's move to the next one. Now sometimes there will be cases when you will find that some examples have negative charge on them, like this SO42 minus, MnO4 minus, and in some cases you will find that there is positive charge. If negative charge is there, rule number 4, if negative charge is there, then it will be on the corner atoms. If there is negative charge, it will be taken by the corner atoms. For example, this is the central atom and these are the corner atoms. Now if negative charge is there, if one negative charge is there, it is taken by corner atom. Two negative charges taken by two corner atoms. If there is a positive charge like in case of our NH4, positive charge is always taken by the central atom. Remember these 2 points, right? Now we will take a look at the formula. Now we will try to understand the formula which tells us how to calculate total number of electrons. Now why there is a need to calculate total number of electrons? Because those total number of electrons will help in drawing the structure, Lewis dot structure. Now total number of electrons are calculated is equal to valence electron of all the atoms in the molecule. What is the meaning of all the atoms in the molecule? For example, we have H2O. Now there are total 3 atoms. So you have to calculate the valence electron of all the atoms. For hydrogen, 1 plus 1. For oxygen, calculate, it's 6. So total number of valence electrons will be 8, right? So after calculating the total number of valence electrons in the molecule, you have to add the negative charge if there is a negative charge, and you have to subtract the positive charge if there is a positive charge. Now these two will be present individually. These two will not be there in a molecule altogether. If the molecule is neutral, that means there is no negative charge, no positive charge. These two will be present, but one of them will be dominant. One of them will be dominant. When you calculate the formal charge, there will be a few cases where central atom will have positive charge and corner atoms will have negative charge. So one positive charge will cancel one negative charge, and finally you have only one negative charge shown in the structure, right? So generally these two will be present individually and not together, and if together, one of them will be dominant. Either positive charge will be dominant or negative charge will be dominant, right? Now we will go for the examples. The first example, that we will take is of H2 molecule. Now since there are only two hydrogens, just draw them hydrogens and make a single bond. There is single bond between two hydrogens, we all know that. Now calculate the total valence electron. Total valence electrons. How many total valence electrons are there? 2. Now calculate the number of bond pair electrons. How many bond pair electrons are there? There is a single bond and each bond carries 2 electrons. So there are total number of 2 electrons in bond pair, right? Now lastly, calculate lone pair electrons. How many lone pairs are remaining? How you will calculate that? Total valence electron minus bond pair electron. You will get 2 minus 2 is equal to 0. So there are 0 lone pair electrons left in the structure, and there is no need to put lone pairs because we already know that this is the final structure of H2 molecule. I will not write this particular formula again. We will do it directly. All right. Let's take a bigger example of O2. Now, what is the total number of valence electron for O2 molecule? Total number of valence electron is 6 electron for 1 oxygen. There are 2 oxygen atoms, so 6 multiplied by 2, you will get 12. Right? Now calculate the bond pair electrons. Draw single bond at first. Draw single bond like I have done. Now how many bond pair electrons are there? There are 2 bond pair electrons. And now calculate lone pair electrons. How many lone pair electrons are there? Total valence electron minus bond pair. 12 minus 2 is equal to 10. Now there are 10 lone pair electrons. Now start filling from the outer atoms, corner atoms. But since we only have 2 atoms, there is no need to find a central atom because there are only 2 atoms. So you can choose anyone as central atom and take other one as corner atom. Now start filling the lone pair electrons. The rule that you have to remember before filling is that the corner atom's octet should be complete. So how many electrons are there at this point for this oxygen? Only 2, which are bond pair electrons. It needs 6 more electrons to complete the octet. So start giving electrons. 1, 2, 3, 4, 5, 6. Now its octet is complete for this particular oxygen. The octet is complete. Fill the remaining one. 4 electrons are remaining. 1, 2, 3, 4. Now calculate the number of electrons for this particular oxygen, and you will find there are 1, 2, 3, 4, 5 and 6. There are total 6 electrons for this particular oxygen. This oxygen is not able to complete its octet. So how you will complete the octet? You will remove lone pair from this oxygen and put a double bond on this place. Now calculate the number of total number of electrons. The octet is complete or not? 1, 2, 3, 4, 5, 6, 7, 8. The octet for this particular oxygen is complete, and octet for this particular oxygen is also complete. If some atom, in our case this oxygen, was not able to complete the octet, so we removed one lone pair from this side and made a double bond to complete the octet of both the atoms. Now let us consider some higher examples. Now we will take the example of H3O plus. Now in this particular case, total valence electrons will be 6 for oxygen, 1 for hydrogen, but there are 3 hydrogens, so you have to multiply it with 3, and there is also a positive charge, and we know that if there is a positive charge you have to subtract it from the equation. Now calculate. 6 plus 3, 9 minus 1, 8. Total 8. Now how many bond pair electrons are there? Bond pair electrons, first make the bonds. 1, 2, 3. So how many bond pair electrons are there? There are 3 bonds, each bond carry 2 electrons. So total number of bond pair electrons is 6. Lone pair electrons, how many lone pair electrons are there? Total valence electron minus bond pair electrons, 8 minus 6 is equal to 2. So there are 2 lone pair electrons remaining. Now hydrogen only need 2 electrons, which are given to it in the form of single bond, right? All the hydrogens have a doublet which is complete. Only oxygen is there that have 1, 2, 3, 4, 5, 6 electrons. So the 2 remaining electrons will be present in the form of lone pair, right? This is the final structure, and the positive charge will be present at the central atom. We have already read that in the rules, right? So that's how you draw it. Let's move to the next. Our next molecule is NO3 negative. Now total valence electron, calculate the total valence electron. There is one nitrogen atom, so nitrogen has 5 valence electrons, plus there for oxygen the number of valence electron is 6, but there are 3 oxygen atoms, so multiply it with 3, and there is a negative charge. In case of negative charge, you have to add the value to the equation. If there is one negative charge, add 1. If there are 2 negative charge, add 2. Now find the total. 6 3s are 18. 6 multiplied by 3, 18, plus 5 plus 1, you will get 24. Now calculate the bond pair electron. How many bond pair electrons are there? The number of bonds are 1, 2 and 3. Number of bonds are 3, so number of bond pair electrons will be equal to 6. Calculate the lone pair electrons. How many lone pair electrons are there? When you calculate the lone pair electrons, you will find it is 24 minus 6 is equal to 18. This is the number of lone pair of electrons which can be present in the form of lone pair, double bond or triple bond, right? Now there are 18 lone pairs remaining. This is a bit hard example, so remember this one. All the previous examples were easy. This one is a bit difficult, a little bit difficult. There are 18 lone pair of electrons, and start completing the octet of corner atoms. You have to start completing the octet of corner atoms, right? So start filling the octet of oxygen atom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We have used all the 18 electrons just by completing the octet of all the oxygen atoms. Now oxygen atoms have a complete octet. Calculate the number of electrons: 1, 2, 3, 4, 5, 6, 7 and 8. Right? Now calculate the octet for nitrogen. 1, 2, I repeat, 1, 2, 3, 4, 5, 6. So nitrogen octet is not complete. Yes, nitrogen octet is not complete. So how to complete the octet of nitrogen? We will remove two electrons. We will remove two electrons from one of the corner atoms and make a double bond. Make a double bond. Now if you calculate the octet for nitrogen, you will find that nitrogen has total number of 8 electrons in the octet. All the oxygens also have 8 electrons in their octet. Now since we know that nitrogen generally forms 3 bond and have a lone pair of electron, but in this particular case nitrogen is making 4 bonds. Sorry for the disturbance. Nitrogen make 3 bonds and there is one lone pair, but in our case nitrogen is forming 4 bonds, which means nitrogen will have a positive charge. But in our molecule we have negative charge. Now from where this negative charge is coming? The example which I was talking earlier, the central atom has a positive charge, but when you calculate the formal charge of individual atom, you will find that this oxygen acquires a negative charge, this oxygen acquires a negative charge, and this oxygen acquires zero formal charge. And when you calculate the total charge, you will find that at the end there is one negative charge remaining, because this negative charge will cancel the positive charge, and what is remaining? Negative charge. This is the negative charge which is shown in this place, right? On formal charge I will make another video. Now we will continue with our examples. Let's move to the next example. Our next example will be NO2 minus. Now total valence electron. Calculate total valence electron. Nitrogen, one nitrogen is there. The valence electron of nitrogen are 5. For oxygen, the valence electron is 6, but there are 2 oxygen atoms, so multiply it with 2. Now there is a negative charge, so add that negative charge, and the final answer will be 18. Right? Now bond pair electron. To calculate the bond pair electron, draw the structure: 1 nitrogen and 2 oxygen. So there are 2 bonds that you are forming right now. So total number of bond pair electrons will be 4. Now lone pair electrons. Calculate the lone pair electrons. The number of lone pair electrons will be 18 minus 4 is equal to 14. These lone pair electrons will be used in the form of lone pair or double bond or triple bond. Now start filling from these electrons from the corner atom and complete their octet. Right? So let's start. 1, 2, 3, 4, 5, 6, 7, 8 are in the bond. Again 1, 2, 3, 4, 5, 6, 7, 8 are in the bond. Now calculate the total number of lone pairs that we have already filled. 6 from this oxygen and 6 from this oxygen. So we have used 12 electrons out of 14. So how many electrons are remaining? 2 electrons. Use the 2 electrons and give those 2 electrons to the nitrogen atom. Now we know that nitrogen form 3 bonds and have one lone pair, right? But in this case nitrogen already have a lone pair and 2 bonds are formed by nitrogen. So that means nitrogen will make one extra bond. And how you will make that one extra bond? By removing 2 electrons from one oxygen and using it as a double bond. Now when you calculate all the atoms have their octet complete. And if you calculate the formal charge, you will find that nitrogen has a formal charge 0, this oxygen have a formal charge 0, but this oxygen have a formal charge minus. That negative sign is shown in this place, right? So that's how you have to calculate total number of valence electron, bond pair electron, lone pair electron, and draw the structure of Lewis dot structure of any. Our next example, SO3 2 negative, will talk about the exception that central atom can have more than 8 electrons. Now first calculate total valence electron. There are the total valence in calculating the total valence electron for sulfur, the valence electron is 6 plus how many oxygen are there? 3, and each oxygen has 6 valence electrons, so 3 into 6 plus there are 2 negative charges, so add 2. The final answer will be 26, right? Now bond pair electron. How many bond pair electrons are there? Draw the structure. 2 on this side, oxygen, oxygen and oxygen. So there are total 6 electrons in 3 bonds that we are making right now. So total number of bond pair electrons will be 6. Lone pair electrons will be 26 minus 6. Total valence electron minus bond pair electrons. So there will be 20 lone pair electrons. Start filling the lone pair electrons from the corner atoms, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We have used 18 electrons out of 20. Right? We have used 18 electrons out of 20. The remaining 2 electrons, give that to sulfur. Now, if you calculate the number of electrons for individual atom, you will find that the octet is complete for every atom, for sulfur and oxygen both. But this structure is not correct, and this will take us back to our statement that central atom can have more than 8 electrons. Can have more than 8 electrons. Why I am talking like this? Because there are 2 negative charges. But if in this particular case, in this particular structure, you calculate the formal charge, and you will find that there are 3 negative charges that are developing on 3 different oxygen atoms. There are 3 negative charges which are developing on oxygen atoms, which is not correct. So what you will do is you will remove 2 electrons. I repeat, you will remove 2 electrons from the oxygen atom and make a double bond. Now sulfur have how many electrons in its octet, which should be octet, but in this case there are 4, 5, 6, 7, 8, 9, 10. So sulfur have 10 electrons. Sulfur have 10 electrons. And if we talk about the covalency of sulfur, then you will find that sulfur have a covalency of 2, 4 and 6. Means sulfur can make either 2 bonds or 4 bonds or 6 bonds. But in our case, in the previous drawing, I draw it like this, making 3 bonds for sulfur, but covalency of sulfur is not 3. So to complete the covalency, either sulfur will lose a bond or will make another bond. So in our case, sulfur will make another bond by using 2 electrons of this oxygen and make this structure of SO3 2 negative. And now if you calculate the formal charge, you will find that there is 1 negative charge on this oxygen, 1 negative charge on this oxygen. Sulfur have 0 formal charge, oxygen has 0 formal charge. So total charge will be 2 negative. That's how this particular structure is drawn. This was the structure for exception. I hope I have covered almost all the examples of different types. You can make your own, you can try your own structures by using this method. This video is already 30 minutes long. I don't want to continue it for a bit long. I can use many examples, But this will be it for today's video. If you have any doubts, you can comment it and I will make another video. I will make another video on Lewis octet rule and I will draw your diagrams, right? Thank you very much for this video. Thank you very much for watching this video and have a good day.